Welcome to this explainer. Today, we're tackling a massive, honestly, kind of philosophical challenge in systems engineering. As artificial intelligence systems produce just an immense, continuous volume of answers, researchers and engineers are forced to confront a deeply practical problem. Who actually evaluates all of this? We're going to explore a paradigm shift in how we measure artificial intelligence, and why evaluating intelligence is, at its very core, an intelligence problem itself. Here is our roadmap for today. We'll start with the evaluation bottleneck, examine the rise of the LM as a judge framework, explore the structural limitations of model-based judgment, break down the critical distinction between consistency and truth, and finally, look at why we need a comprehensive verification architecture. Let's start with part 1, the evaluation bottleneck. We have to begin here because while human evaluation has always been the gold standard in this field, it carries some pretty severe constraints. Simply put, human review is slow, it's expensive, and above all, it is incredibly difficult to scale. A person can carefully examine a few responses, sure. But think about the AI tools we're all using every single day. When a system starts generating thousands or even millions of outputs globally, asking human reviewers to grade every single one of those, well, that quickly becomes an impossible, insurmountable task. Which brings us to part 2, LLM as a judge. To solve this massive scaling issue, researchers have turned to an increasingly common, though somewhat controversial, mechanism. Instead of relying on a human to read and evaluate every single answer, another language model is just asked to step in and act as the evaluator. This evaluating AI can actually perform several distinct tasks. It might compare two different responses side by side. It may score an answer based on accuracy, relevance, clarity, or completeness. It can even provide detailed feedback, explaining exactly why one solution is stronger than another. And this approach dramatically accelerates the whole evaluation process. A model can judge vast numbers of outputs quickly and consistently. That allows researchers to filter out weak answers, improve training data, and seamlessly guide optimization loops without running into human fatigue. And this takes us to part 3, limitations of model judgment. The very second we make a language model the judge, we introduce some profound structural risks and technical complications. We absolutely have to stop and ask this critical question. How do we know the AI judge is actually right? The answer is not at all obvious. We have to remember that a language model doesn't directly possess truth in the way we think of it. It generates its judgments merely from patterns, instructions, provided context, and its internal representations. And this brings up our core danger. Confidence is not proof. An AI judge's evaluation might sound incredibly confident and carefully reasoned, yet a fluent, highly confident explanation from an AI judge can still fiercely defend a completely incorrect conclusion. The model's eloquence essentially masks the reality that it is simply predicting language. It's not actually verifying facts. Crucially, these aren't just minor technical imperfections. They are deep structural limitations. An AI judge exhibits several well-documented risks. For instance, it may prefer longer answers simply because they appear more thorough. It often favors responses written in a confident tone. It tends to reward familiar arguments over unusual yet perfectly correct ones. Its judgment can even be unfairly influenced just by the order in which answers are presented to it. And perhaps most dangerously of all, it may agree entirely too readily with reasoning that resembles its own. The generator and the evaluator often share the exact same training patterns, assumptions, and blind spots. Which leads us to part 4, consistency versus truth. This shared structural risk brings us to a really fascinating philosophical and technical divide. Think about it using this analogy of two students. Imagine two students who studied from the exact same, completely incorrect textbook. One student writes the test answer, the other student grades it. Because they share the exact same flawed foundation, the grader is going to mark the incorrect answer as correct. If one AI generates an error and another AI validates it, their agreement does not establish correctness. They agree, for sure, but they are both wrong. The crucial difference boils down to this. Consistency simply means that different parts of the system happen to agree with one another. Truth, however, means that the system remains accountable to external evidence, logic, and reality. While consistency and truth can certainly overlap, they are absolutely not identical. If both the generator and the judge misunderstand the same issue, the evaluation loop just reinforces the error rather than actually detecting it. Let's look at how this compounds within a self-improving evaluation loop. In a fully automated pipeline, A model generates candidate solutions, the AI judge selects the strongest one, and then that selected answer is used to train the next generation of the model. If the judge has even a small blind spot, that error gets repeated and amplified across thousands of decisions. Over time, the entire learning process becomes totally dependent on the quality of the evaluator. The evaluator is no longer just passively measuring progress, it is actively shaping the entire direction of progress. So how do we fix this? That brings us to part 5 of verification architecture. To prevent these accumulated errors, we must shift our perspective entirely and build a broader, multi-tiered verification architecture. We really need to move away from treating evaluation as just a final, static step, simply scoring a question at the end of a pipeline. Under the energetic paradigm, evaluation is a dynamic part of the intelligence process itself. Every single judgment determines where future computational effort and influence will be invested. A high score grants an idea more computation. A low score abandons a pass. Because of that, no single judge should automatically possess unlimited authority. We have to place a robust verification layer directly beneath our AI judge to govern the evaluation process itself. What this verification layer does is allocate checking effort based strictly on the importance, the uncertainty, and the ultimate cost of an error. Routine, low-risk decisions shouldn't consume massive resources, right? But for high-stakes conclusions, things like scientific novelty, medical decisions, or irreversible actions, the system must invest much greater verification energy. An energetic evaluation system might check judgments against external evidence, actually execute code to see if it runs, or perform stability tests to ensure a conclusion holds up under different prompts. And when a disagreement is unresolved, it appropriately escalates the issue to human reviewers. The goal here isn't to eliminate the AI judge, that would sacrifice scale, but to allocate our evaluation effort intelligently. This brilliantly captures our ultimate conclusion today. A good judge evaluates answers. A trustworthy system evaluates the judge. The LLM as a judge framework is an incredibly important advance that makes evaluation faster, richer, and vastly more scalable. But it doesn't solve the fundamental problem of truth. It merely moves it up to a higher level of abstraction. Once AI can generate answers and judge answers, intelligence ultimately requires governing that entire relationship between generation, evaluation, evidence, and correction. The central question moving forward is whether the system knows when its judge should be trusted and when it needs to be judged again. Which leaves us with a truly fascinating question for our next explainer. What actually happens within a coordinated system when multiple AI agents evaluate, challenge, and correct one another? Does adding more judges necessarily guarantee a closer alignment with the truth? Join us next time as we explore the architecture and the implications of multi-agent evaluation.